Okay, good day everyone. For today's lesson, we're going to discuss about Euler's theorem. But before that, let me remind you, dapat napanood nyo na yung ating naunang video tutorial which is about Euler's totient function kasi gagamitin natin yung concept na yon in performing operations involving Euler's theorem. So before we start, okay, let us first define Euler's theorem. According to this theorem, if n is a positive integer and the GCD or the greatest common divisor of a and n is 1. So it means a and n must be relatively prime. Then a raised to phi of n is congruent to 1 mod n. Okay, so let us have an illustration. So let us show that Euler's theorem is true for n is equal to 10 and for all a is less than n. Okay, so the first step is we have to find first the phi of 10, okay, or the phi of n. And since n here is 10, so we have phi of 10. Now applying rule number 3 in Euler's totient function, we can have the prime factors of 10, which are phi of 2 and phi of 5. Diba? Now we apply rule number 1, which is phi of a prime number is the same as the prime number minus 1. And then we have another one here, 5 minus 1. So 2 minus 1 is 1. And 5 minus 1 is 4. Therefore, the phi of 10 is equal to 4. And if we're going to list down all the numbers which to determine the value of a, no, so a must be less than n, and the numbers less than 10 are 1, 2, 3, 4, 5, 6, 7, 8, and 9. Now what we're looking for, the value of a, it must be relatively prime to n. So, alin ba dito sa mga number na to ang relatively prime kay 10? Alin yung magbibigay ng GCD na 1? 'Di ba? So, syempre, we have 1. We also have 3, 'di ba? 7 and 9. Apat 'yon, kaya apat din dito tayo dito. Okay? Now, according to this theorem, so let us represent these numbers now to generalize the term. So let us use a. So a raised to 4, according to Euler's theorem, since the phi of n is equal to 4, so we have a raised to 4 here that will give us a remainder of 1 when we divide it by 10, right? So for our first value of a, so we have 1 raised to 4. So that will give us a remainder of 1 when we divide it by 10. So for the second value of a, we have 3 raised to 4. So 3 raised to 4 is equal to 81, right? So that's 81. And that will give us a remainder of 1 when we divide it by 10. Next value of a is 7. So we have 7 raised to 4 is congruent to 7 raised to 4 is 2,401. And that will also give us a remainder of 1 when we divide it by 10. And for the fourth value of a, we have 9 raised to 4. So 9 raised to 4, that's equal to 6,561. And that will also give us a remainder of 1 when we divide it by 10. Okay? So meaning, pwede nating magamit yung Euler's theorem, di ba? This is true for all, for a is equal to 10 and for all a is less than n. Okay? Now, let us have an example. Okay? In performing this operation, pwede nyong magamit yung mga previous lessons natin, Fermat's theorem, no, yung pagsosolve ng modular arithmetic. But for this example, we're going to use Euler's theorem, no, to solve. Okay, so let us have example number 1. So example number 1, let us find 5 raised to 12 mod 36. So meaning we're going to identify the remainder when we divide 5 raised to 12 by 36. So the first step is to find the phi of 36. Okay? And pwede nating kunin ang mga prime factors nito. Pwede nating gamitin yung may power din na prime factor. Kasi bakit? Prime factors ng 36 are 2 raised to 2, dalawang 2, at dalawang 3. Diba? So that's applying rule number 3. And then applying rule number 2, so any number raised to a prime, so that will be, yan, ganito ang mangyayari, diba? Then 3 raised to 2 minus 3. That is rule number 2. That's a previous lesson natin. Now, 2 raised to 2 is 4 minus 2. That's equal to 2, diba? Then 3 square minus 3, that's equal to 6. So that is equal to 12. Okay? And since the GCD of 5, that's the value of a, and the value of n is 36. So the GCD of 5 and 36 is 1. Okay? Therefore, we can conclude that since this is the same as our exponent here, so the phi of 36 is the same as this, okay, we can say that 5 raised to 12 will give us a remainder of 1 when we divide it by 36. Okay, so the remainder is 1. Now let us have example number 2. Now let us find 2009 raised to 6 mod 9. Okay, so again, the first step, we're going to find the phi of 9. And phi of 9, pwede natin siya isulat as 3 square, diba? Sorry. Should have a phi sign symbol. So that's equal to phi of sorry, should be phi of 3 square, diba? Then applying rule number 2, that will give us 3 square minus 3, and 3 square is 9 minus 3 is 6, right? And since this one is the same as the exponent, and the GCD of 2009 and 9 is 1. You can check, no, lahat ng factors ni 9, alin lang doon yung pwedeng makapag-divide din kay 29, and that is 1 lang, no? So they are relatively prime. So because of that, we can conclude that 2009 raised to 6 is congruent to 1 mod 9. Okay? Now, let us have another example. Example number 3. Okay, let us find 3 raised to 44 mod 10. So, the first step is to find the phi of 10. Nakuha na natin to kanina, di ba? So, phi of 10 is the same as the phi of 2 times the phi of 5. And using rule number 1, that's 2 minus 1 and 5 minus 1. So that is 1 times 4, that is equal to 4. And since the GCD of our A, which is 3, and N is 10, is 1, so 3 raised to 4 is congruent to 1 mod 10. 3 raised to 4, hindi 44 guys ha. So tingnan natin yung pagkakaiba kanina. Sa example number 1 and 2, yung nakuha nating value ng phi of n is the same as the exponent. Kaya nakapag-conclude na kaagad tayo that this one gives a remainder of 1 when divided by a certain value of n. But in this case, this is not the same as this. Okay, so we have to perform more steps, no, to find the remainder. Now, luckily, no, so ang given natin ay 3 raised to 44. So, kailangan ma-erase natin sa 4, 'di ba? Para maging 1, malimit natin or mapababa natin yung number sa 1. And luckily, no, yung 44 is divisible by 4. 'Di ba? 44 divided by 4 is equal to 11. So, we can write here 3 raised to 4 raised to 11 mod 10, right? And applying Euler's theorem, 3 raised to 4 is congruent to 1. So that will be 1 raised to 11 mod 10. And 1 raised to 11 is equal to 10. Therefore, 3 raised to 44 is congruent to 1 mod 10. Okay. Now let us have another example. Example number 4. Let us find 7 raised to 133 mod 26. Okay, so let us find first the phi of 26. So the prime factors of 26 are 2 and 13. So applying rule number 3, we have phi of 2 times the phi of 13. And applying rule number 1, phi of 2 is 2 minus 1, and phi of 13 is 13 minus 1. 2 minus 1 is 1, 13 minus 1 is 12, 1 times 12 is equal to 12. And the GCD, no, GCD of our A, which is 7, and our N is 26, is equal to 1. So we can say that 7 raised to the phi of 26, which is 12, is congruent to 1 mod 26. Right? Now, ang given nating exponent dito ay 133. Diba? So, we can use division algorithm, no? Para magkaroon tayo ng exponent na 12. So, anong gagawin? So, di ba ang ginawa natin doon sa calculator, pwede nyo itong gawin. So, yung 133 natin, i-divide nyo ng 12, di ba? So, magkakaroon niya ng decimal dito, di ba? 11 point something, di ba? Yun yung tinuro ko sa inyo nung nakaraan. So, kukunin nyo lang yung 12, yun yung 12, and then, syempre, times yung 11, di ba? And then, para hindi na kayo paulit-ulit sa calculator, di ba, tinuro ko sa inyo, 11 point, some decimal part here, di ba? So, ibawas nyo lang yung 11 para matira lang ay yung decimal part, and then, i-times nyo yon sa 12. Okay? And that will give us an answer of 1, meaning ang remainder natin ay 1. Okay? So, 133 can be expressed into 12 times 11 plus 1. Okay, again, anong ginawa? 133, dinivide ng 12. Nagkaroon siya ng sagot na 11 point. Diyan, may mga decimal part dyan. So, binawas natin yung 11 para maiwan ay yung decimal part and then multiply it by 12 to find the remainder. Okay? Now, therefore, we can have here 7 raised to 133 is congruent to, now how do we write this? Paano natin siya isusulat? So, since, una muna, 7 raised to 12, diba? And then, erase natin ito nung 11. And this one, syempre, may times 7 pa tayo dito, raised to 1. Diba? And then, we have mod 26. Okay? Now, so applying the Euler's Theorem, 7 raised to 12 is equal to 1. Diba? So, 1 raised to 11 times 7, then mod 26. And this is 1. 1 na siya. So, may iwan na lang sa atin ay si 7 and then mod 26. Therefore, no, 7 raised to 133 has a remainder of 7 when we divide it by 26. Okay? Now, let us have another example. How about if we have calculate 7 raised to 30 mod 15. Okay. So again, the first step is to find the phi of 15. And applying rule number 3, phi of 15 is phi of 3 times the phi of 5. And phi of 3 is 3 minus 1. Phi of 5 is 5 minus 1. 3 minus 1 is 2. And 5 minus 1 is 4. So the phi of 15 is equal to 8. And the GCD of 7 and 15 is equal to 1. So 7 raised to phi of 15, which is 8, is congruent to 1 mod 15. Now, again, we can do the division algorithm, no, kasi 30, diba? 30 yung given natin. So, if we divide 30 by 8, no? So, 30 divided by 8, 3 point something yon. So, that will give us 8 times 3. And then yung decimal part again, i-multiply nyo sa 8. Ang magiging sagot nun ay 6. Okay? So, 30 is equal to 8 times 3 plus 6. Ibig sabihin, mayroon tayong dito 7 raised to 30. And we have here 7 raised to 8. And then, i-raise natin ng 3. And then, times 7 raised to 6. Diba? Then, mod 15. Now, so hindi na natin kailangan pahabain pa, no? 1 na to, alam natin 1 na ito. So may iiwan na lang sa atin, that's using Euler's Theorem, is 7 raised to 6. Diba? Pero ang laking number pa rin yan. Diba? Napakalaking number pa rin. So, paano natin gagawin? So, again, ang pwede natin gawin dito, pababain ulit natin yung value. No? So, let us first find 7 raised to 2. 7 raised to 2 is equal to 49. Diba? And 49, when we divide it by 15, ilan ang matitira? 4. Diba? So, 4 mod 15. So, ibig sabihin, yung 7 raised to 6, pwede natin siyang isulat na 7 raised to 2 and then raised to 3. So, yun yung gagawin natin dito. Okay? So, we have here 7 raised to 2 raised to 3 mod 15. And since 7 raised to 2 will give a remainder of 4, that will be 4 raised to 3 and then mod 15. 4 raised to 3 is equal to 64. Diba? And when we divide 64 by 15, we can now conclude that 7 raised to 30 is congruent to 4 mod 15. Okay. Now, let us have another one. Okay. Let us find, I think this is the last example, no, for this lesson. So, 23 raised to 130 mod 25. Okay. So, first step is to find phi of 25. Now, using rule number 2, we can rewrite this as 5 square, diba? Phi of 5 square. So, that is equal to 5 square minus 5. And 5 square is 20 minus 5, that's equal to 20. Right? And the GCD of 23 and 25 is equal to 1. So, 23 raised to the phi of 25, which is 20, will give us a remainder of 1 when we divide it by 25. Thus, okay, 23 raised to 130. Okay. So again, ang laking number niyan, 'di ba? So gawin ulit natin yung division algorithm natin. Okay? So 130, i-divide natin yan ng 20. Okay? Gawin nyo na lang sa calculator nyo para masundan nyo. So ang lalabas dyan ay 6 point, yan, may mga decimal points. So ibig sabihin 20 times 6 yon, 'di ba? And then ibawasin nyo yung 6 para ang matira lang ay yung decimal part and then i-times nyo kay 20. Ano ang natira? Natira ay 10, 'di ba? Okay. So meaning yung 23 raised to 130, pwede natin siyang i-rewrite as 23 raised to 20 raised to 6. And then 23 raised to 10 and then mod 25. Now, alam na natin ito ay 1, 'di ba? So, ang maiiwan na lang is 23 raised to 10 mod 25. And ang laking number pa rin ito, hindi pa yan kaya ng calculator, 'di ba? Hindi pa kaya yan. So, again, pwede natin siyang paliitin. Okay? Pwede nating paliitin yan, no? So, 23 i-raise natin sa 2. Yan. So, ang 23 raised to 2 is equal to 529. Tama? And if we divide it by 25, that will give us 4, a remainder of 4. So, alam niyo na yung kasunod. Diba? So, yung 23 raised to 10, pwede natin siyang isulat as 23 raised to 2 and then raised to 5. Diba? Mod 25. So, we have here 4. 4 ito. Raised to 5 mod 25. So 4 raised to 5, that is 1024 mod 25. So madali naman, kahit medyo malaking number kasi 25 yung number. So alam natin, no, maiiwan na lang is si 24. Therefore, 23 raised to 130 is congruent to 24 mod 25. So, dito pwedeng kahit hindi 2, no? Kung kaya nyo mas malaki pa, pwede nyo gawin. No? So, yan, as long as tama yung application nyo dito. So, that is about Euler's Theorem. So, sana natutunan nyo kung paano i-apply yung Euler's totient function para ma-solve ang isa na namang modular arithmetic problem. Okay? Now, for your quiz number 2 in number theory, ipopost ko na lang ulit ito sa ating LMS. Okay? Maraming salamat.